We're going to look at a problem on scaling using a class constant. So call it Space Shuttle. Write a program to print the following Space Shuttle figures. Use static methods with nested loops and a class constant size to scale the figure. So class constants, we use all capital letters. You don't have to, but that's just by convention. Again, class names will start with a capital letter. Method names will always start with a lowercase letter, and class constants will always be capitalized. Each print statement should print at most one of the same character. In other words, use loops to get more than a single or a set of characters to print. Methods and loops should be used to avoid redundancy. Changing the size or scaling a size will affect both the height and the width of the figure as shown. Your code should be able to scale by any factor of 2 by adjusting the class constant. So size 2, 4, or 6. We won't worry about the odd scaling factors. Okay, so what are we trying to draw? This is our guy, our space shuttle. So usually we start with size 4, which is this figure here, and you want to look at your figure and you want to say, okay, how many components or how many pieces does this figure have? And those would be the methods that main is going to call. So if it's easy to tell, I mean, some people would have different choices here. How many choices do you see? Well, here's size 4. This is size 2. It got smaller by a factor of, well, different things change differently, so you have to be kind of careful. And then here's size 6 for the same image. So I see pretty clearly three different components. So we can jump over to Eclipse and maybe start a new. We're gonna do a lot of work on paper here, but I just want to get my project started, my Java, my class created. So go over to my Java project chapter 2. You can click into that source code folder and do a new class, and we'll call it capital Space Shuttle. We'll have a main function and we'll hit finish. And let's put some commenting in up here. So I'll put my name, Pure Science 142, you put the date. And then we want to describe the program. Well, we have that description here, so maybe I can just sort of summarize that. Program draws, uses a class constant to draw space shuttle figure to different scales. Okay, so public class space shuttle. Right below that, we're going to declare our constant public final. So that's the keyword for constant. It's going to be an integer and it's going to be called size. And then we're going to declare it and assign it to size 4 initially. So our first goal is to try to get size 4 to work. And then ideally, anything that would depend on the number 4 is actually depending on the constant size. And then we can change the size to 2 or 4 or 6 or 8 or any factor of 2 and get the appropriately scaled figure. Okay, but before we do any coding really, we look at the figure and we decide, well, how many components or pieces does that figure have? I see a clear 3 components. So I'm going to call it sort of the top or the tip. We'll call that function draw top. We'll invoke that function, and then we see the middle. So again, I'm going to call that draw middle. I could just use top, middle, and bottom here, but I'm using the word draw in front just to indicate that we're going to draw that. So you can see draw the bottom, or the base, let's call it the base. And you can see the word draw here is a little bit redundant. So maybe instead I just come in here and I say each function we'll draw part of the shuttle. And we'll not call that draw top, we'll call it top. And we'll call this middle, and we'll call this base. And so that has the same effect, and I could come back to this comment and I could make it a complete sentence if I want, capitalize the E, put a period, little details like that. Okay, so we have errors here because we have not declared these three functions, top, middle, and base. They should be occurring at the same level as main. So we'll hit return after main ends, and we'll go public static void top, open brace, hit return. It should set up the space for that method. And notice the error on that method went away. I'm going to do the same thing for middle. Public static void middle. You could do mid as well if you wanted. You could sort of try to use head, body, legs. That might work as well if you're changing the names a little bit based on anatomy. Public static void base. Things I would try to stay away from in naming is like, don't assume that the reader, the person who's reading the code or looking at it, knows what you're talking about. So you know what, you wouldn't want to say, you know, B, because for B for base, they're not going to know that. Or, you know, bottom two or something. You know, you want your description to be easily understood by someone who just comes along and looks at the figure and goes, oh, I see what the top should be. That's clearly the top. Okay, so now we're going to leave Eclipse and we're going to jump back over to Notebook here and try to figure out, how do we do this? Meaning, how is it going to change based on the size? So just like when we use our nested loops, we're going to use nested loops here. And but what's changing not only is the, you know, so notice what's happening in the top. What's changing here is the size, and then the number of rows is changing, and then also how many spaces you have in front of that caret symbol is changing based on the size. So this is just for the top. Maybe I write up here, top. And so I'm gonna put the sizes in order, 2, 4, and 6. In size 2, we have for the top 1 row. In size 4 for the top, we have 3 rows. And in size 6 for the top, we have 1, 2, 3, 4, 5 rows. So we could try to figure out what the loop is that determines the number of rows right now. And then we could print something in those rows to make sure it works. But it turns out it's actually easier to kind of figure out what's going to happen within the row. So within each row, the number of spaces in front is not changing, at least in the top. That space is the same as that space is the same as that space. So that's gonna, if not, we have to sort of do something a little bit differently, and we're gonna see that down on the base part. But in each of these tops, the number of spaces in front of this caret is the same. So let's count them. 1, 2, 3, 4, 5, 6. So size 4 has 6 spaces in front of it. Size 2, oops, has, I'm using the left and right keys. 1, 2, 3 spaces in front of it. And size 6, I'm gonna guess, has 9, just based on the pattern. 9, yep. Okay, so hopefully these are linear relationships. If they are, then we can use y equals mx plus b. For the base, it's actually what we would call a bilinear relationship, where it's linear in 2 variables. So again, the row, we always have a first row. So the loop, you know, the rows are going to be for row equals 1 to whatever the top is. And then in each row, what's going to happen Well, in each row, we have to do something. We have to print the spaces. And then we have to print the caret. And then we could print the spaces on the back end, but really what we need on the back end is a new line character. So new line. And notice, I could put those together and make that a print line statement that prints the caret. So what's that upper limit on the rows? That's that linear relationship. And, maybe we can just look at it. And here it's based on the size. So if we think of size as the x variable, and row as the y variable, and we think, okay, y is equal to m times x plus b. And this whatever formula I get is going into this box, is the upper limit of the rows. So again, it's going to be row. So what's m? M is the change in y over change in x. So this is 2 each time that's changing. And this is also 2. The rows are increasing by 2 and the size is increasing by 2. So m, 2 over 2, which is 1. And the y-intercept would be, well, what happens if we go back here to 0? So we're not going to have size 0, but if I did go back, then I'd have to take 2 away from here. We get -1 there. So b equals -1. So the formula is the row equals 1 times the size minus 1. So this is from row equals 1 to row equals size minus 1. And let's put that in here. It's 1 times size really, but and then minus 1. So that formula is the upper, sorry, I crossed that out. Let's try to not do that. It's the upper value of my row. So it's going to be row, and then when I code this, it'll be row is less than or equal to this. Okay, so then we're going to go to spaces. And you could think of spaces here as depending on either the rows or the size. Let me think for a second. So the spaces are going to also depend on the size. And so sometimes it's helpful just to redraw this table. Size is 2, 4, 6. How many spaces do we have? I think it's 3, 6, and 9. So again, if we think of this as x and that as y, spaces start at 1, and they go up to what? Well, whatever that linear relationship is between the size and the spaces. So again, we're going to use the same idea, y equals mx plus b. Notice I'm not doing any coding. This is way better to figure this out on paper. This is changing by 3 each time. These are changing by 2, so the slope is the change in y over the change in x, or 3/2. This is where it's important that we're only going by 2s, factors of 2, because, how do you draw 1.5 of something? 1.5 space, you can't. Okay, so then we have the spaces is equal to 3/2 times the size, and then it's going to be plus b, whatever the y-intercept would be. And again, I can just kind of sneak back up here to 0, and that's the same distance. So decrease that one by 2, that one should decrease by 3, and it will also be 0. And think about this, 3/2 times 2 is 3, 3/2 times 4 is 6, 3/2 times 6 is 9. So this will be 3/2 times the size. Good. And so that loop will be inside the row loop, and then we'll print our caret. So now we're ready to do the first function, which is top. So I come over to idle. I'm sorry, come over to Eclipse, and I'm going to say for integer row equals 1, row less than or equal to, back to our paper, size minus 1. And again, size is all caps. And then row plus plus. Increase the row by 1. Open brace, return. Then I want to do a second nested loop. It doesn't like that. Public. Pause for 1 second. So in my declaration of the class constant, so over here it's saying I need to change size to static, and it's saying public final static. I think I can also do public static final, which is how it's shown in the PowerPoint. So I forgot the keyword static there, and notice the size switched from regular typeface to an italic. Oops. I should have caught this earlier. It switches to an italicized text, and that's going to be for a constant, the all cap. Okay, so here it is now, size minus 1, and we're going to do a second loop for integer spaces. Starts at 1, and then spaces is less than or equal to 3/2 times size. And there's a problem here, but I want you to see it, so I want to leave it there for a minute. 3/2 times size spaces plus plus. So then we go back to our pseudocode. That's my nested loop. Inside, after I print my spaces, so it's not inside that loop, it's after that. So inside this loop, we need to print the space. System. Single space, and that's the requirement in the assignment that each print statement should print at most one of the same character. I have to use a loop here. I have to use the loop here because the number of spaces in front is changing. So I don't want to print 3 spaces for one size and 1 space for another. I have to use a loop that's dependent on size. So the print statement just has 1 space in it. It's the looping that's going to print multiple copies of that. Now, if we don't have anything else in our code, we're not going to know whether it works because we won't have printed anything after the spaces, so we can't tell what's happening. But after the spaces print, we then want to print on a new line, well, on the same line, but then a new line, the caret. So outside of that loop, I'm going to use a print line statement where I print the caret. And that should achieve, for size 4, printing 3 carets. Let's see what happens. Not gonna, oh, it did work. I actually don't think it did. 1, 2, 3, 4. So there's 4 spaces there, and this guy should have 1, 2, 3, 4, 5, 6 spaces. So you couldn't necessarily tell that it didn't work, but when you do the next part, your spacing will be off. And I just want to talk about why. Here we only have 4 spaces in front, and there should be, according to my table here, in size 4, there should be 6 spaces in front. So what happened is this 3/2 is integer division. 3 divided by 2 in Java is 1, not 1.5. So I either need to put 1.5 here, or I can go, 3 divided by 2.0. And now if I run it again, that creates a double, and now that pushes them over to 6 spaces in front. 1, 2, 3, 4, 5, 6. Yay. Okay, good. So that's the top. Attempted to make a separate video for each of the components, just so that it's not so long, but I don't know. Let's look back where we are. So the next part would be the middle. And if you look at the middle, there's sort of different components in there. In the beginning of the middle, we have to print spaces. Then we have to print equal signs. Then we have to print a plus. Then we have to print equal signs again. So what does that sort of pseudocode look like? So again, maybe I pull out a fresh sheet of paper and I write, middle. At the top. Meaning I'm going to work on the pseudocode for the middle part of the figure. Oh, you know what we didn't do? We didn't check the size, changing the size here. So what we should check, I'm going to put a space in there, have that spacing correct. Actually, technically, I should put spaces in here. Division's a little harder because you kind of want them close together, but that's okay. What we didn't check was changing the size. So if I change this to size 2, 2 things should be affected: the number of spaces in front and the number of rows that get printed. So it should just be 1. Yep, there it is. One caret on top of size 2 with 4 spaces. 1, 2, 3, 4. Oh, just 3 spaces in front. 1, 2, 3. And then we'll switch to size 6. And that should generate 1, 2, 3, 4, 5 carets. 1, 2, 3, 4. It does, with 1, 2, 3, 4, 5, 6, 7, 8, 9 spaces in front, which is what we have. And then we could also go to size, 16 if we wanted. And, I don't know how many carets that should generate, but we could figure it out. Let's go back to size 4. So this appears to be working, and that's good. I think I will actually pause this video and create a second video for one each for middle and base. You could actually try middle on your own before you watch the video and see how it goes. It's often these things that the same thing when we're meeting in class. If I'm doing the coding, everything's like easy, not easy, but like way easier when I'm doing it. When I ask you to kind of to take over, things get harder, right? We'll come back, we'll do middle on the next video.